Uh, Thank you and much welcome once again on the lesson. Um, we are going to cover chemical effects of electricity and electrical principles, and today we are going to cover the simple cell. We are going to look at the simple cell, its construction, and its working principle, and finally we are going to look at the faults of a simple cell. Now, what is a simple cell? A simple cell is basically a device that converts chemical energy into electrical energy. In its construction, it consists of two different metals. That's the electrode and an electrolyte solution as or an alkali, for example dilute sulfuric acid, salt solution. We can look at the diagram. It depicts the construction of a simple cell. We can see we have the dilute sulfuric acid as an electrolyte. We have the electrode. On this other side we have the zinc electrode. On this other side we have the copper electrode. The copper has been used on the anode, while zinc on the cathode, and we have an ammeter and a resistor. The ammeter will be used to measure the current flowing through the resistor, and we will get to understand the working principle. How does it work? The electrodes are made of two different metals, and the more reactive, that is electropositive metal, tends to undergo oxidation and gives up electrons readily. It becomes the anode, negative electrode. The less reactive metal will become the cathode, that is the positive electrode, as it has a weaker tendency to lose electrons. The cell voltage depends on the metal in the reactivity series. The further apart the metal the reactivity series, the bigger the voltage of the cell. The purpose of an electric cell is to convert electrical energy to convert chemical energy into electrical energy. And we are going to look at that. As you can see in the other slide, we have the reactivity series, the electrochemical series, where potassium is in the top, highly reactive, through to carbon, and we can look more on the reactivity series. Let us look at faults in a simple cell. We have polarization. Polarization is the formation of a filling of hydrogen atoms on the copper anode. These bubbles prevent full contact of the copper electrode on the electrolyte, thus increasing the internal resistance of the cell. When we talk of internal resistance, this is the resistance that occurs within the cell the opposition of flow current within the cell itself, and it leads to draining the energy. You cannot get the full current of the cell. And now, how do we overcome polarization? We overcome it by using a depolarizer, such as potassium dichromate, which removes the hydrogen vapors as they form, so as to allow the cell to deliver steady current. Now we have another fault known as local action, and this is the rusting of the zinc. Zinc contains certain impurities such as iron, and when placed in dilute sulfuric acid, it decomposes, leading to the eating up of the cell. Now, these small cells are formed short-circuited by the electrodes. The result, that current flow causing corrosion. And how do we prevent local corrosion? We can prevent it by rubbing small amount of mercury on the zinc surface that forms a protective layer on the surface of the electrode when metals are used. When two metals are used in a simple cell, the electronic cells may be used to predict the behavior. And just as we see, the metal in the higher series acts as the negative electrode, and vice versa. For example, zinc electrode on the side is negative, and copper is positive. Thank you, and welcome. If you have any concerns, you can raise, and have a great evening.